Okay, so this week we're going to do some revision of trig. So the first lesson we'll look at the 1 trig. Second lesson we'll look at the 2 trig. In terms of the 2 trig we've already covered. And then the third lesson we'll do a bit of preview into next year's trig. So first of all, just to recap, to get the second angles, for sine we take away the first angle from 180. For cos, take it away from 360. And tan we take it away, we add it to 180. So you get the first angle by doing arc sine, arc cos, arc tan, and then get the second one. Then once you've got the first two angles, you can then get all the multiple angles in the region by adding or taking away 360 to both angles. And you can keep doing that until you've got all the angles in the region. So there's an infinite solution, and there'll only be a small number in the region of the ones in the exam though. Then we have reciprocal functions, which is next year stuff, which is in red. Sorry, this is year 2 trig, which we've already covered. So I've put that in red. We'll look at that next lesson. So sec is 1 over cos, cosec is 1 over sine, and cot is 1 over tan. We then have quotient identities. Quotient just means fraction. So we have tan theta is sine theta over cos theta, which theta could be anything. It could be something like x. It could be 2x. So tan 2x would equal sine 2x over cos 2x. We have cot theta is cos theta over sine theta. And again, we'll look at that tomorrow because that's a year 2 identity. We have the Pythagorean identities. So sine squared plus cos squared equals 1. And again, theta could be anything. It could be x, it could be 2x, it could be 3x, it could be x at 1. Whatever theta is, as long as it's the same for sine squared and cos squared, it'll always equal 1. Then you can rearrange that in 2 ways to get sine squared theta is 1 minus cos squared theta, and cos squared theta is 1 minus sine squared theta. Then we have some year 2 identities. 1 plus tan squared theta is sec squared, which again we can rearrange to get tan squared by taking away 1. And we get that identity by dividing the original by cos squared, because sine squared over cos squared gives tan squared, cos squared over cos squared gives 1, and 1 over cos squared gives sec squared. We also have 1 plus cot squared theta equals cosec squared theta, and we get that by dividing the original identity by sine squared theta. Or we can rearrange that a little bit to take away 1 from both sides to get cot squared theta equals cosec squared theta minus 1. So all this stuff in red is year 2 identities, which we looked at this year. There's going to be a lot more next year we look at, so that's why we've done some more than just the black ones this year. We thought we would get a few more in this year, so that next year's trig, it doesn't feel as overwhelming as it would normally. Now there's also this correlative identities, which to be fair, I've only seen one exam question where you've had to use them, but they're still useful to know. And it kind of comes from the Sokotor right angle triangle. That sine 90 minus theta is cos theta, and cos 90 minus theta is sine theta. So if you have something like sine 40, you can change into cos 50. If you have cos 10, you can change that to sine 80. Just take away the angle from 90, and then you can change sine and cos. Now, that's not too useful, but it's good to know. And there's some general tips. So you cannot cancel a term from both sides in the equation. So instead, we take it to one side and factorize. So there's an example of that, which we'll talk through in a bit. If there's a square term, then it's very likely that you're going to use a Pythagorean identity. The only exception is when there's only one term. So if it's something like sine squared x equals 0.5, then you can solve that just by square rooting both sides. Yeah, but if you can't do that, then it's likely you'll have to use Pythagorean identity if there's more than one term. And try to get an equation in terms of 1 trig functions, either sine, cos, tan. It's normally just sine or cos, and factorize to get it to equal to 0. Yeah, if it doesn't equal 0, there's no point in factorizing. It has to be equal to 0 for the factorizing trick to work. So we're going to look at, and if the angle is not just theta, make a substitution and change the limits. So again, there's an example of that, which I'll point out. So we're going to look at the first 3 questions in the practice sheet I'll give you, and I'll talk through them. And all the other questions on that sheet are similar to these 3 exam questions. So first one, always check the interval that we're solving for. So x is between 0 and 360. and check the accuracy of the answer once. So this isn't going to become too important this year, but it's going to be more important next year. Check that the angles are the same. So it's 2x with the sine and 2x with the cos. So that's fine. The angles are the same. So I can make a substitution, and I'm going to call it y. So y is 2x. As soon as I make a substitution, I have to change the limits. So I'm going to times the x values by 2. So y goes between 0 and 720. So my new equation is 5 sine y equals 2 cos y. So now in the next step, I've got a sine and a cos. So if I take it to one side, I can't factorize. There's no point in doing that just yet. Instead, sine and cos, so my alarm bell should be ringing. We can make it tan. So divide both sides by cos, because tan is sine over cos. So divide by cos y. So 5 sine y over cos y, and 2 cos y over cos y. So on the right-hand side, the cos y's cancel out, and you get 2. On the left-hand side, sine and cos turns into tan. So we get 5 tan y equals 2. Divide by the 5, so tan y equals 2 over 5. Now that's the equation we just need to solve. So you get the first angle, so arc tan gives 21.01. Add 180 to that to get the second angle for the tan. Now we check the region, so it's 0 to 720. So we can definitely add 360 to both answers to get more answers. So 381 and 561. So there are answers for y, so I'm just going to write them clearly. There's 4 answers for y. I'm using lots of accuracy, more than just one decimal place, so I don't get rounding errors when I go for x. And then to get x, I need to divide by 2, because y is 2x, so x is y over 2. So divide those 4 answers by 2, and round it to one decimal place, as the question says. And there you go. There's the 4 answers. Easy 5 marks. And you could use a calculator, you could use Solvent to check you've got them right. Okay, next one. I think this was in one of your assessments this year, and I remember lots of you expanded this for no reason and changed tan into sine over cos again for no reason. So remember, check the region of the angle. So it's minus 180 to 180 degrees. Now it's factorized and it's equal to 0. So if it didn't equal 0, then I would have to expand and make it equal 0. But the fact that it equals 0, I know that 2 things times together, if that equals 0, there's only one possible answer. One of them has to be 0. If that didn't equal 0, it equal 2, then there's an infinite possibilities. So you could have 1 times 2, you could have a half times 4, you could have a third times 6, etc. You could have an infinite option. However, if I've got 2 things times to make 0, one of them has to be 0. So don't expand. Instead, solve each bracket separately. So 1 at tan theta equals 0. So tan by itself, let's take away the 1. Get the first angle. Get the second angle, so it's 180 plus, because it's tan. And then we want to go from minus 180 to 180. So if I add or take away 360, it'll go outside the region. So there's no more answers. Move on to the next one. So 5 sine theta, take away 2 equals 0. Get sine by itself, so 2 over 5. I get the first answer. Get the second one, so it's sine, so we take away from 180. And again, if I can't add 360 or take away 360 to get any more answers in the region. So they're my only answers. And it hasn't told me how to round the answers, so I'm going to do it to a sensible degree. Since it's the angles in degrees, not radians, then 1 decimal place will look fine. Otherwise, 3 significant figures will also be fine. So there's the 4 answers. Yes, its key trick was was already equal to 0, so the 0 was the important bit. And last one we'll talk through together. So x is between 0 and 360, and 4 sine x equals 3 tan x. So first thing to think about is if I take it to one side, I can't factorize. There's no point in taking it to one side just yet. Sine and tan, well, there's nothing I can do just yet. But tan, I can change that into sine and cos, so then at least I've got something to work with. I've got more than one sine. So I'm going to rewrite it as 3 sine x over cos x. Now, I could have wrote the 3 at the front. Remember, 3 means 3 over 1, so it's 3 sine x and 1 cos x. It's just a fraction times a fraction. Yeah, 3 over 1 times sine x over cos x gives you 3 sine x over cos x. Yeah, if you're a bit wobbly on that, look over your GCSE notes. Okay. Now I'm going to multiply both sides by cos x to get rid of the fraction. So 4 sine x cos x equals 3 sine x. Now this is the bit where you might be tempted just to cross out the sine x from both sides. However, with trig, we're not allowed to do that. In fact, in maths, we're only allowed to do that if we know the thing we're crossing out can't be 0. Because remember, we're not allowed to divide by 0, and sine x can definitely equal 0. So instead, we take it to one side and factorize. So there you go, I took away the 3 sine x, factorize out the sine x, and we get that. Now the sine x by itself, you can imagine brackets around that. So I've got 2 possible brackets. So I've got sine x equals 0, or 4 cos x take away 3 equals 0. So solve the first one, get the first angle, 0, take it away from 180 to get 180. Now we can add or take away multiples of 360. Now, if you look when it's between 0 and 360, it looks like it could add 360 to 0, but there's no equal sign on that 360. So I can't put 360. Now, in an exam, if you did do that by mistake, you wouldn't lose a mark. You don't get marks for putting answers that work outside the region, but you're not allowed to put any incorrect ones that are inside the region. So they're the only 2 answers for that one. Solve the next equation. So get cos by itself. So take the 3 and the 4. And then solve that. So first angle, 41.409, etc. Now, when I'm working out these angles, I'm using the answer button to get the next angle. I'm not rounding. I don't want any rounding errors until the very end. So second angle, so for cos, it's 360 minus. And then that's it. I can't add or take away 360 to those. So my final answers are 0, 180 from the first equation, 41.4 and 318.6. So can you have a go at doing the exam questions? And these are real exam questions for the year 1 trig. And then tomorrow we'll look at the year 2 trig, the bit about the sec, cosec, and cot, and in particular the other Pythagorean identities with the sec squared and the tan squared, etc. So any questions, just get in touch and let me know, see if I can help.